the late lagginess. As always, some tech issue. Um, to kick the ball off rolling, I would like to introduce you guys to Enrico. If he's actually one of the fellow organizers, so I'm gonna let him say a few words. So let me just give him Enrico. Enrico, you can start.
Hello, can you hear me?
Yes, we all can hear you.
Okay, wonderful. Thank you so much, and thank you, Fernando, for your introduction. My name is Enrico Gaetani. I work for HP, and it's a big pleasure for me to kick off this afternoon this series of webinars organized by my app. And my welcome is, of course, on behalf of Intel and HP. You know that we collaborated to the production of this webinar series. And in particular, we are pleased here to kick off the first one that is all about OpenStack. You know that Intel and HP are strong partners, and we are collaborating in a number of different activities in the IT industries. And we decided jointly to organize this series of webinars to share with you our commitment in the open source and in particular on OpenStack. And this is because both Intel and HP are platinum members of the foundation. We hold the seats on the board of directors, but this role, I think that most importantly, really represent the commitment of Intel and HP organization on this platform. Intel developers work with the community to expose the Intel hardware technology to OpenStack software module and to extend the OpenStack technology to improve security, compliance, high availability, manageability, performance, and of course the end user experience overall. We as HP are working with the OpenStack Foundation to develop the HP Helion OpenStack distribution with the intent of really accelerate and facilitate our customer experience that are using or are going to use the OpenStack platform for their workloads. So that said, thanks again for your participation on behalf of Intel and HP. And I hand over now to my estimate colleague Christian Frank for the technical presentation.
Hello, thanks Enrico. Thanks for the kind introduction. My name is Chris Frank. I work for Hewlett-Packard in the cloud pre-sales team, and I've been with OpenStack pretty much for the last 3 years. So my main role is within HP to build and design clouds based on OpenStack, and also bring OpenStack into what we call SIT. So having said this, I think we need to start with a key statement. If you could advance the slide, please. Thank you. Wonders of modern technology. We haven't. Oh, one less. Exactly. Thank you. The cloud, and that's a bold bet that HP is making here, which says like the cloud of the future will be based on open source. What does that mean? At one point, we stopped developing our own cloud software. We stopped developing things that would run only on HP hardware. We stopped developing things that only work with HP software, but we decided the future of the cloud is open source. And within open source, the biggest cloud project is OpenStack. By no means, it's not the only one. but that's the one where we took the big bet and says like everything cloud going forward will be based on OpenStack. Next. If a company like HP goes open source, what does it basically mean? We had to set up some core principles. I don't want to bore you with all the details, but the key is whatever we do, we commit back to trunk. And the second thing is we do not fork. So we have no intention of creating a separate HP branch of OpenStack. And as we go on through the presentation, we also have no intention to do that for Cloud Foundry. So the goal is for us, and it's a clear commitment to open source, and the goal is to stay true to trunk and commit as much back as we can. Next. So the first question that usually arises is, what is OpenStack? I mean, OpenStack is a lot of things. There's as many fun pictures out there showing that it's a myriad of projects. It's now part of what's called a big tent. All the projects are in. But as its core, what OpenStack does is it takes the free core resources that you have in a data center, which is compute, network, and storage, and manages that. And it manages it through software, meaning that if you need a new computer, need a new network segment, or need a new volume of disk, it's OpenStack who goes out and provides it for you, either separate or together. And that's what OpenStack does. It runs, again, a set of shared services, and then it runs on top of standard hardware. And standard hardware means, in our case, of course, the HP Reliant series, but it will run actually on whatever you want to. And that is true for all the distributions of OpenStack. It brings a dashboard where you can look into the consumption of your resources, where you can initiate resource requests, such as deploy a virtual machine or deploy a network. But there's something that it does not bring, which is pretty important, and that's mentioned there as under your applications. Next. So, and that makes it very clear what OpenStack is not. OpenStack is a cloud operating system. It runs the cloud for you, but it does not provide services that you normally associate with a cloud from an end user perspective. So there's no file sharing, there's no calendar synchronization. So OpenStack is not own cloud. You can run on cloud on top of OpenStack as one of the applications, which is actually a nice fit to get a working cloud or a working environment for your employees, co-workers, co-students, partners in the local soccer club to share information with. But OpenStack is just taking care of the infrastructure. Anything that has to do with applications comes later. Towards the end of today, we'll start looking into applications because infrastructure is becoming more and more a kind of commodity. But as far as OpenStack is concerned, and for the next couple of slides, please keep in mind all we do with OpenStack is we take care of infrastructure. Next. Why open source? It's agile. It's the biggest project, open source project in the world right now. It has a governance body that's truly multinational, multi-corporeal, so to speak. So it has influences from all over the world, from all major companies, from smaller companies. And with having the biggest set or area of developers available, it is really fast and really quick. It has, and that is not true for all of the open source projects, it has a long-term vision. It's very strong on focusing on APIs and making sure that everything the platform does can be done from APIs, constant APIs with long-term support, and there's a strong focus on interoperability. So within this open source community, we as HP, we do have a place. Next. Next. Yes. And which is basically saying, oh, we're one of the leading contributors. I'm not going to bore you with the details. I just want to go on to my favorite slide of cloud. We just briefly saw a glimpse. Next. Yes. Pats and Kettle. If you haven't heard about it, then take it for 2 years. If you have heard about it, then can go back to sleep for about a couple of minutes. Because that's the key of understanding cloud, is to understand the service model behind cloud and the idea of services behind OpenStack. And also, it's very important to understand the service model once we go into application space. If we look at traditional systems in IT, and I've been the sysadmin for a long period in my life, your machines, you tend to lovingly name them, give them like Oracle Cluster 01 and Oracle whatever and SAP so and so. You have individual machines with individual tasks, individual operating systems, individual uptime needs, individual patch schedules, and if one of them fails, the main focus is to get them back to health. Not a, but exactly that machine. Now when we go into the cloud space, things change. So the machines that actually the worker that deliver the results to the end customers, they are not individual anymore. There's a lot of machines that do exactly the same tasks, that communicate using message buses that have no state information whatsoever inside, except for things like databases or message queues, which allows us to basically to kill or lose these worker VMs if something happens. It gives us the ability to scale as we need to. If you have the example that I usually quote is Netflix, although they are not on OpenStack. We just imagine there's Netflix, Super Bowl, halftime advertising, probably all available machines need to stream that, and that goes back down afterwards. So what we are talking here is about scale out, the ability to rapidly scale, to rapidly provision new machines to pick up a certain task if the need is, and drop it if the need goes away. So as we go forward, try to keep that in mind where OpenStack comes from, and that's the area of Kettle. Meaning we are very good at deploying a lot of machines in a very short time. We are very good at deploying loads and loads of machines, talking about hundreds and thousands of numbers. But it's not OpenStack's forte to look after single high available machines. That's not a judgment saying, oh, everything has to be bad, Kettle is the only way to go, and pets are bad. No. It's just, if we talk about cloud, if we really want to consume cloud resources, we need to understand that the applications behind that actually provide whatever you need, whether it's data streaming, file sharing, web UIs, they need to follow certain principles that turn them into Kettle. And one of it is statelessness, so that you actually can lose a process and nothing happens. Coming back to Netflix, and I'm not affiliated working with Netflix, they have something to prove that, and that's called the Simian Army. The Simian Army is a set of tools that includes the Chaos Monkey. And the Chaos Monkey is basically a software tool that runs through the entire infrastructure and kills processes and services. And if the Chaos Monkey runs and the end users have no interruptions, then the platform is okay. Right? So it is, that's the idea of the Kettle, of a security and high availability in numbers and in statelessness. That's the key thing that we need to keep in mind when we talk about cloud. So let's have a brief look at traditional applications. Next. So look at traditional apps. Like how do you actually get an app out there? It's a bit tedious. You have your template, you provision your services, you configure your infrastructure, install all the runtimes, and the more complex the application gets, the more runtimes you will need. You need to get your services, you define monitoring, you define HA for that particular application. And then once you're finally done, you're happy with testing, you push it out and run. Pretty cumbersome. And it's still, I mean, that's where we decide between traditional and cloud native apps. It's still at a point where we're looking at a lot of individual steps. Next. Cloud native apps, whether you run them on a PaaS or not, are created in a way that they no longer need dependencies. So if we look at a PaaS like Cloud Foundry or role-based or even traditional Java applications or Ruby or Python, a cloud native application is self-contained, and there's the word contain, which probably in a few slides will lead me to the word of containers and then to Dockers, but it's self-contained, and that's where the key starts. You give the developer the ability to push this out, because there are no more dependencies to resolve. Once there's of course testing to be done. That's a matter of process. But within the technology allows you to build the application, you push the code out, and then the services on the cloud, then the platform that runs it takes care about scaling, provides the redundancy in form of runtime environments, and heals whatever fate might befall the node, and let it be just the chaos monkey switching it off. To be able to do this, again, we need to be stateless, and we need to have a system in place that manages the dependencies. Next. So what does it do for us? There's a big transformation. If we go with the cloud, if we go cloud native, there is one is scale out. So the ability that OpenStack and other cloud software gives us is the ability to scale in numbers, to go from 100 web front ends to 1,000 web front ends in no time. because there is a new TV series out, there's a new ad running, so you need to get your front end supported. You need to get tenfold increase of service. So we're no longer talking about scale up or flex up that we had in the virtualization world, where we said like, okay, we add a new virtual CPU and 2 GB of virtual RAM. That's not what we're talking about here. With an OpenStack, what you want to do is talk about scale. Open source, yes, we've covered that. If you have a lot of machines, if you have a lot of simple services, it becomes actually simple and distributed. There's people using the word microservices at this point, which I like to avoid. A lot of the development on cloud native apps is driven from the grassroots, meaning that it's not decided by like a steering committee of an IT world, but decided by a line of business or a group of students. Says like, oh look, this is a cool app. Why don't I organize something like sharing bed and breakfast rooms, and you happen to get an Airbnb platform out of it. Also, last key is APIs. All of this only works together if you have documented and stable APIs. If you have them, you don't need to spend a lot of coding hours into integration. But the key, there's a key change when you go cloud that affects the application. Scaling, simple, distributed microservices, and everything is run around APIs. Next. Just skip that one. Good. What's our vision? And I think I need to speed up a little bit. I like to talk. What's our vision? We envision that IT and the world will be led by developers. We believe that it will be open source based and be all about data. So the key things that we want to look at going forward is developers, open source, and data. Data is the one part that we absolutely won't be covering today, but probably in the later stages of the webinar. Next. And as we said, open source, developer-led, open source based. If we look at all the key things, operating systems, the server side, not desktop side, server side is Linux based now by a great margin. Web servers, almost more than half are based on open source projects, either Apache or Nginx. The world's biggest content management system is WordPress. So there's millions of really reliable, really good open source software out there, and that is key. That will drive the world, we believe. Next. And we have very famous support in believing this. Even the President of the United States agrees that if you want to leave a footprint, you need to be able to code. So that's going back to what we already said. We believe in developers and development, and also in open source. That is actually not a photo, but a LinkedIn video, which we're not going to play, but just for copyright reasons. That's a YouTube video. Next. Good. Let's go a little bit deeper. 3 things that we need to for all kind of 3 words or terms that we need to talk about. At the bottom of the cloud, if we build our cloud infrastructure, if we want to actually run something and make money out of it, the core is our infrastructure, where we kind of believe that this is something that we've covered. We've done it many times. We know how to do it. The operating system for the infrastructure of choice for us is OpenStack. Next. Once we go up in the chain, that's where the development comes in. That's where the platform as a service that we decided to go with, Cloud Foundry, resides, where you have an environment that supports the languages of our time, PHP, Ruby, Java, Node.js, whatever you want. Cloud Foundry works very nicely together with Docker, and there we are linking back to like 10 minutes ago when I was talking about the containers and more than containers as a noun with the things, with a package that contains the dependencies. So the whole idea behind going up into the platform as a service is that every time you push out an application, every time you deploy an application, you've automatically resolved all dependencies. That frees you from any reasons, any patching needs, that frees you from any version control. You just know at the point in time, because it's self-contained in a container, pardon the pun, it will work. So that takes a lot of worries about away from application developers. And then on top of that, next, we see a service catalog, meaning some kind of catalog services where you can give your users the ability to pick and choose what they need to install on their machines. That's not so much important if you run your own clouds for your own business, and you're probably okay with the 2 lower layers. But if you run a kind of a service provider cloud for other people's business, that's the kind of the entry point, the service catalog, where you provide the application services, provide applications, maybe even development services to the customers, and have them choose. Service catalogs, there are many. We have one which is called Cloud Service Automation. There are many others. There is an OpenStack catalog that's being worked on. We'll see in Tokyo how far that's got in Liberty. So yeah, that's kind of the top layer, the icing of the cake on the whole application chain. Next. So now that I've set the groundwork, I need to introduce the how shall I say, the foundation that we have, which is the Helion OpenStack. So let me start on the right. What is Helion? Helion is our brand for everything cloud. Whatever interpretation you come up with, it's probably correct. Whether it's there's a gas called helium, and it's also a word for sun. So whatever interpretation you have, it's correct. Helion is our brand for cloud. It's not a product; it's a brand. Within that brand or product family, it's probably better. Sorry, it's not a brand. within that product family, the infrastructure as a service part is OpenStack, which is a distribution of OpenStack provided by HP. Not more, and also not less. It provides a standard OpenStack environment with certain add-ons from HP, but it's at the core, it is OpenStack from trunk, like the OpenStack you would get from Red Hat, Mirantis, SUSE, and Rackspace, and whatnot. The packaging is different. We package different networking drivers. We will package different storage drivers, but in the end, it's OpenStack. So if you want to add things that you know from other distributions, you're entirely able to do so. We might not have tested it, and I'm not saying that we might not have inadvertently broken things, but even OpenStack is a distribution of OpenStack. It works on any type of hardware, so it's not explicitly tied to HP hardware. Obviously, we like it. Of course, we do like it to be run on HP hardware, but it's not tied to it. Last but not least, if you're familiar with OpenStack, you know that there needs to be an underlying Linux on OpenStack, and that's something that we bring together with the Helion OpenStack distribution. We'll bring a purpose-built Linux distribution just for that case, which is called HLinux. So the whole package that you can actually download from our web pages is complete. It's feature complete. So we'll bring our Linux and we'll bring a Helion OpenStack, and it runs. It comes in 2 editions: the free community edition that you can download, and then we have 1 edition that comes with support and patching. Next. What do you do with it? Basically, it is infrastructure and a service. You can run testbeds on it. You can provide the infrastructure to customers. You can provide the infrastructure in-house. Anything that you want to do with infrastructure, you can do with Helion OpenStack. Next. On top of Helion OpenStack, we put the Helion Development Platform. The Helion Development Platform is, again, a distribution of an HP distribution of Cloud Foundry, which is an open source platform as a service. And again, the same principles apply. We are true to trunk, so it's Cloud Foundry has an API. Stuff that you develop on the Helion Development Platform to the Cloud Foundry API will run on any other Cloud Foundry platform with the same version. Like OpenStack, Cloud Foundry does evolve, so also APIs evolve, and so yes, there is needs to be within kind of the same age range, but it is a true to trunk distribution of Cloud Foundry. Next. So what is Cloud Foundry? Interestingly enough, it was developed originally by our colleagues from VMware. Was spun out to Pivotal in 2011, and at one point became open sourced, and it's now driven by a Cloud Foundry Foundation, pretty much using the same principles as the foundation behind OpenStack. It provides two things. It provides a development environment or development plugins that support your developers in writing the code, packaging the code, and deploying it. And then on the other side, on top of OpenStack, it provides a runtime environment where all the dependencies are being resolved, where the high availability is concerned, is taken care of, and pardon me, and where all the stuff that normally for application as sysadmin would do are being done by the platform. So two parts to it: the IDEs and developer experience. Now the right-click in Jenkins, push to whatever environment you have, and then on the other side, and you see it on the screen as DEA, the Docker pool of execution systems that take the applications and actually run them. Next. Again, briefly, we're one of the contributors. Cloud Foundry has been the Cloud Foundry Foundation has formed. There is a Cloud Foundry Summit not too far away, and we are part of the Foundry. Unlike with the OpenStack Foundation, for the Cloud Foundry Foundation, we are actually a founding member. Next. So what do we do on top of Cloud Foundry, which is more and above the trunk Cloud Foundry? We have an admin user interface. We have put in Docker containers, an application gallery, and added a couple of build packs. Build packs in Cloud Foundry speak are basically the parts of Cloud Foundry that resolve the dependencies. So if you for a simplistic view, if you write an application in Python, you publish it. In your manifest, it says, okay, it's Python, and you also need access to MS SQL or MySQL. Then the appropriate build packs will be grabbed and combined with your application to the container that then in the end runs the application. So there's no database admin to do. There's no, like, do I have the right Python on my on the execution node? And happens at build time, and if I'm staying with Python, as Python the versions roll, new versions of your applications will have new versions of Python in their build packs. So again, there's no need for patching, and the containers do not interfere with each other. Next. How Cloud Foundry is integrated in OpenStack. The little screenshot you see at the bottom, that's taken from Horizon. So basically, we've integrated, or Cloud Foundry, so it's not just us who do that. It's integrated in normal OpenStack management. So it's absolutely seamless for the OpenStack admins to administer also the Cloud Foundry runtime. I've mentioned earlier the integration with Trove or MS SQL. Cloud Foundry actually, if it needs a database, and actually uses the OpenStack services. such as Trove for databases, and there's many more to come. So it's a very exciting integration taking place between the infrastructure services as OpenStack grows and provides more and more OpenStack, like more and more infrastructure services. You can see that at the same time there's more and more consumption of these services from the PaaS space from Cloud Foundry. Next. So if we look at all of this together, then we have reached the point which is the kind of the what we wanted to show today, the Helion Cloud Platform. At the bottom layer is Helion OpenStack, taking care of all the infrastructure. The upper layer, the Helion Dev Platform, the Cloud Foundry, which gives us the Cloud Foundry lifecycle services, the tight integration into OpenStack by actually using OpenStack services for Cloud Foundry functions, such as Trove for databases, and then we can, going back into the bigger HP world, we can expand it into vertical or idle or this all the other nice things that we have to offer. I usually tend to say that HP is an ITIL company, so if there is an ITIL process, we have at least 2 tools for it. So yeah, the entire world kind of HP software becomes accessible. Next. If you want to get started, it's fairly easy. For prototyping, for light-duty production, go and get yourself the development platform, the community edition, the Helion OpenStack community edition. They're freely downloadable. There is a short link at the bottom of your screen where you can start, and I can start today. For production, we have we struggled with how we should call them, so we decided not to call them at all. We have the Helion OpenStack and the Helion DevPlat in the editions that are supported, where we offer support for, and the method that the way that we are offering these is based on a subscription, on a yearly subscription. Next. So here, like I said earlier, we're getting close to closing now. As I said earlier, the whole Helion platform is it's just a family of products, or product family. The many other things I mentioned, cloud service automation, but there is integrated solutions like the Helion Rack or the Helion Content Depot, which is basically Swift in a box, so to speak. There's Helion Eucalyptus, which is talking to your Amazon Web Services compatible private cloud. We do actually run managed cloud services where we take clouds in-house and run them. So the whole Helion portfolio is all about taking clouds, taking infrastructure, opening it up, and moving into what we call a hybrid world between private and public services. Next. So, big thing coming up really soon. There's the OpenStack Summit. It's October 27 to 30 in Tokyo this time. Unfortunately, the early bird registration ended yesterday, but it's still not the full price. So if you have any doubts, any possibilities to go. These summits, if you are in any way interested in OpenStack, the key source of information, that's where the developers and the users meet and decide on the fate of the platform and the product. So it's not HP who decides what happens in OpenStack. It's not AVM, Rackspace, Ranches, SUSE, you know what I mean. It is the users, the community. That's the beauty of OpenStack. So if you have any chance, go there. And I can only say is like people kind of get frightened and say it's like, oh man, Tokyo is so far away and so expensive. No, it's not. I actually, living in Europe, in the middle of Europe, it's much cheaper to go to Tokyo than it was to go to Vancouver last year. Next. In addition to the OpenStack Summit, we also have the Cloud Foundry Summit. And that's much closer. That's in Berlin, actually, November 2nd and 3rd, Monday, Tuesday, after the All Hallows weekend. It's in the middle of Berlin. The Cloud Foundry is much smaller as OpenStack, so don't expect the full we meet a conference center completely attitude. It's much smaller, it's much nicer. It's in Berlin, and again, that's where the future of the platform will be decided. That's where the users meet the developers, where the directions for the next features are being kind of agreed on. So if you're considering this for your company, I can highly recommend that you go. Next. And that kind of brings me to my last slide. Thank you very much for attending, for sitting through me talking almost for an hour now. And for the last 5 minutes, I give the mic back to our esteemed organizers.
Unmuted.
Thank you very much, Christian. I appreciate all that. Okay. All right, guys. I really want to say a big thank you to Christian for his very thorough presentation. Reminder, I'm going to send you guys an email tomorrow. It's going to be a thank you email as well as a link for the video that we're going to post up. So be on the lookout for that. Also, we're also going to be sending out a survey that's going to be included. It's going to be carrying some cool stuff. And just a friendly reminder, we do have the second webinar. It is going to be it's going to be on 2 Tuesdays from now, September 15th. It's going to be with Etienne Content. He's going to be our second speaker. He's going to be deploying and pushing a web app with Cloud Foundry. With that, guys, I just want to say a big thank you to everyone that showed up, to Christian and Enrico for helping us host all this. And have a great night, guys. If anyone here has any other questions, Frank, they could probably ask it down in the little chat. That's if anybody has any questions. Okay, guys. I'll see you next time. Cheers.
Okay. Thank you. See you next time.